Welcome back to my channel. Thank you very much for supporting me on this channel. As you can see today, we are here again to complete another installation of 5 solar panels, 590-watt solar panels from Jinko Solar. So I'm going to be showing you as much as possible, the much I can show you, because you can see the roof is a very high roof and it's those old kinds of roof and I cannot do much. And so I'm also going to just try my best to do what I can do. Now, first of all, let's check out the panels. You can see these are not your regular kind of panels. These are 590-watt Jinko solar panels, monofacial panels, half cut. We have 5 of these panels because we are going to connect them in series to a hybrid inverter inside. We have already installed the inverter and the battery, 4 kilowatts inverter and a 5 kilowatt hour lithium battery. Now the hybrid inverter has a nominal voltage of about 380 volts, minimum voltage of about 85 volts, the maximum of 500 volts. If you connect all these panels in series, the VOC multiplied by 5 or the VMP multiplied by 5, you will get around 215 to about 260 volts, which falls within the range of 85 to less than or equal to 500. You can see why we chose these panels and the number. You can even connect up to 6 and sometimes even 7 of the panels to that inverter to be able to charge the batteries. Then we have this cable. This is a 4 cable. One of the good sides of using hybrid inverters is that when you connect the panels to the input of the inverter, you don't have to worry about big size cables, because when you connect the panels in series, current from one of these panels is the same for everything when you connect in series. I'm going to show you the nameplates shortly. You check, you see that the wattage is about 590 watts and the open circuit voltage is about 52 volts. So when you divide it, we get the current about 11 amps. So we are going to be having nothing more than 11 amps flowing through this wire. This 4 cable can conveniently handle 11 amps. So don't need to worry much about that. And it's a 600 volt cable. Come and check. So it falls within the voltage range and also the current range. So it's rated 600 volts. There are some 6 cables that are not up to 600 volts. You can see. So just make sure you check, do your proper check before you get any cable. So it means this cable can handle voltage of over 600 and also can handle 11 amperage of current. Now before we move any further, we are going to check the open circuit voltage of these panels. I want to do the test for this one, then whatever we get, just assume for the rest. So these are a hypothetical panel. Now let's see. So this is a multimeter. So just to give you an idea of the voltage, DC volts. So we are having 48 volts, 48.9 volts. Let's say 49 volts, 49 volts per panel. So just do the math. 49 times 5, that will give you the plus or minus the amount of input voltage you are going to get for the hybrid inverter that will enter into the hybrid inverter as input voltage. Then the current remains 590 watts divided by 48.8 volts. You get the current. So it's going to be less than the current because of cable losses and other kinds of losses, like maybe the intensity of the sun. If the intensity of the sun is high, the current will be high. If the intensity of the sun is low, the current will also adjust to the intensity of the sun. So we are getting nothing more than 11 amps from this connection. So we have 4 cable to handle that. Then we have this, and also let's test the short circuit current. The short circuit current rated on the panel is about 14 amps. So I'm going to bring this panel out a bit to where the sun is to go, so that we can check the short circuit current to see what we get from there. So let's see. You must do this test before carrying out your installation to be sure of what you are going to get when you get up there. Because when you finish connecting, most times you don't really have the luxury of going back to do any correction. So you must make sure you do the appropriate checks to ensure that the result is close to the specifications written on the nameplates. Okay, now I'll have to face it to where the sun can reach it so that I can get something good out of it. So lying it down now, I'm going to come up with my clamp meter, take it to amperage measurement. So when I remove the probes to get accurate reading, so just come. You are meant to short circuit the terminals of the panels to be able to get the short circuit currents, but not for too long. So we are just going to test and see, then we remove it. You can see 12 amps, 12.49. So, and the rated one is about 14 amps. So let's quickly remove it. So that is for that. That's passed the test. And so we are having this for this panel, the same brand, Jinko Solar. So we assume that the value is true for the rest panels. Mind you, before you do installation, make sure you test every panel, because there are sometimes when you test some panels, you will not have any output for the VOC. Just know that that panel is faulty. So you have to take it so that you can exchange it for a better one. So I've tested the panels before I bought it here. So I just had to do this installation, you understand? Because there's no time. So that's it. I'm going to be using these screws and this machine to be able to fix my rails on the roof. This is an old roof. I don't want to hit with a hammer because the impact on the roof will be too much, and you cannot do that without having any leaks later in the future. So I don't want a situation whereby you now have to come to start removing the panels so that they can do maintenance on the roof. So I just have to do it once and for all. Use screws. But when you're using screws, the impact on the roof is not that much. Your drill has to just put the hole. So when it goes inside, then it's easier for it to just get to the wood, and that's all. And make sure before you use any screw, make sure you're using a 3-inch screw, not 4 inches. If you're using 4-inch screw, when it goes into this profile, you have just about 1 or 1.5 inch to go into the wood. But if you're using a 4 inches, you have a lot to go inside the wood, and the more you keep drilling, you keep getting this one worn out. So and when it's worn out, you're not able to use the screws and this machine. You now resort to nails. So I don't want that to happen. So that's why I got shorter screws, so that it will be easy for my screws to go into the wood. It just has to pass through this profile. When it passes through this profile, then we have just a small length of the screw that will enter into the wood. And you have the flash bands. You already know how to install panels on the roof. I've talked about that in my previous videos. So no much talk about that. We have flash band, and also I also try to make sure I use this gum. This is a silicone gum. Now when you mount your profiles, even if you are using a flash band, there are times where you still have 1 or 2 holes where you need to cover. So at such points, this one will come in handy. After mounting your profiles and applying your flash band, there's need for you to also use this one to get extra protection for your roof, so that you're not going to have any problem with leakage in the future. So this one is also important as well. Just fix it in, then press it out to bring out the gum. When I go up, if I have the time, I'm able to show you how I'm going to do that as well. All right, I think that's all I need to know for now. I have my bolts and nuts. And everything is set. So the next time you see me, I'll be on the roof showing you some guidelines on how to go about installing panels on old roofs using these profiles, using flash bands, silicone gums, screws, and nails. There are times my screws might not work. I might go there and find out that the screw doesn't work. So I also have to get nails as an alternative. I bought nails too, but I pray the screws work so that I don't have to stress myself that much. Then we have ropes to be able to tie the panels from the ground and lift it up. So thank you. Please make sure you subscribe to the channel and click the like button and let me know where you're watching the video from. Thank you very much. And again, you need to know that in positioning panels, you have to be strategic about it. You don't just come and mount panels anyhow because that's the most favorable point. You need to use the space or the parts of the roof where you get the most sun for that particular day. In Nigeria is located in the northern hemisphere. And so in the northern hemisphere, the sun rises from the east and sets at the west, passing through south. So it means we get the peak sun at the southern side. So most times when you go to site, just try to use your compass. Get your phone, download the compass app, check the direction of the south, and make sure your panels is facing the south. Then if you are using a controller based system, you can place some panels on the south and place some on the west, because in the evening time before the sun goes down completely, you get to see it around that direction, the west direction, because it sets at the west. Rises in the east and sets at the west, passing through the south during the peak hours in the afternoon most times. So make sure if you're using a hybrid system, all the panels are supposed to be on one direction. Don't share it. The intensity of the sun has to make the voltage distribution to be level and equal. So you don't have some amount of voltage flowing through this panel, flowing through two, then you have another X amount of voltage flowing through three, and you have Y or Z amount of voltage flowing through another six. So you don't scatter panels on the roof for hybrid systems. Make sure they are on one side. So make sure you minimize the space on the roof to place the panels in a way that all the panels are on one side, whether there's sun there or there's no sun. If you're using a hybrid system, you are limited to placing the panels on one direction, and make sure it's either the south or the western direction. So this is west, this way, then this is south, this way, it's south. So it's coming from here. So it goes like this from this point down to that side and it ends there. Okay, so let's just go up and fix the panels and do what we have to do so we can leave here on time. All right, this is exactly what I was telling you about. I'm up right now, and fortunately, the battery of this my drill machine just got exhausted, and I can't use it anymore. So I have to go and get the spare battery. So before I get the spare battery, let me quickly show you what I've been able to do so far. So far, I've mounted up to about 5 profiles for the first side on the roof. I'm still going to mount another 5 extra on top. This time around, I'm not going to do 2 or 3 down, because as you can see, 2 times the length of the panel is longer than the length of this roof. So there's no way it's going to fit in. So I had to just do it straight up, 1 to 5 up to that side. And so this is what I've been doing, and you can see the screws on top, the profiles, and I'm sitting on one of the profiles. So all you need to do is just to get the screw, position the profiles where you need to put them, use the machine to drill it in, and make sure the flash band is there. Sometimes you discover that there's some clearance between the profile and the roof, and that space will give room for water to go inside and make the roof to start leaking. So what you do is just to get your gum, your epoxy gum or silicone gum, and apply it inside to provide extra sealing on the roof. So this is what I'm going to do for every part that I need, and there are clearances between the profiles and the roof. So I'm just going to do that for everything, and I also check around some parts I step my foot on. You can see it's an old roof, and so there's nothing much you can do. You just have to apply it on the obvious holes that you can notice to avoid leakage. Sometimes you might not be able to avoid all the leakage that can come from this kind of roof, but you'll be able to reduce it to a large extent.
Done with the installation of the 5 panels. I'm so sorry I could not show you the step-by-step procedures of how I mounted panels, because a lot of issues came up. At some point, it started raining, and you know it's not easy filming on this kind of roof. So, and we're also working with time. We really didn't have enough time on our side, and right now, the day is already getting dark. And so, this is the best we can show you. We're done with mounting of 5 panels with connected cable. We're going to do all the connection inside. If time permits, I will also show you a thing or two from inside. So that's all you need to know for today. Don't worry, in my next videos, there are more installations that will come up, more installation videos. I'll make sure I keep showing you videos like this to make sure I educate people across Africa and across the globe, give them tips on how to get started with their solar system installation journey. So that's my goal.
We were able to mount all the panels on the roof, but we couldn't complete the installation that's connecting the cable to the inverter's PV input. And so that's what we came here to do today. And we've already routed the cable from the roof. We use these pipes, these conduit pipes, with clips and bends. That bending tool normally used for bending your wires. Electricians call it bending spring or bend spring, anyone you want to call it. So we use that to arrange the cables in these pipes using clips, saddle clips, or tower clips, anyone you want to call it. So, and this is the hole where we passed the wire into. So, and what I'm going to do right now is to connect the cable to the PV inputs, and before then, connect to the breaker, DC breaker, and also the surge protective device, DC surge. Then I'll connect it also to the PV input of the inverter. I've already demonstrated that in my previous video. Now this is the practical scenario on how to do that. We've already installed this inverter some months back. This is just the time for us to come and fix the panels. So just watch me as I do that. Thank you. Here we have a breaker. We have a DC breaker. You can see it's 16 amps. It's rated 16 amps. The panels, the highest current that we're expecting from the panels is about 11 amps. So if there's a surge, it should be going to, let's say, 20 amps, 25 amps, and this 16 amps will be able to break. You understand? So at that point, so put this one here, and also the DC surge protector is here. Initially, I bought this enclosure box, yeah, to be able to house all these protective devices. But then I discovered that right now this is 6-way enclosure box. I already have four four ways occupied. So if you have 4 ways occupied, then it means you only have space to add one more. So I just decided to use that as a golden opportunity to get a separate breaker box for the DC components of the protective devices. So this DC surge and this DC breaker are the DC components of the protective devices. Then while this AC breaker and this AVS, they are the AC components of the protective devices. So right now I'm just going to going to fix this one side by side with this. Then I'll connect it. We already know how to connect it. Loop the inputs to the SPD, then connect the earth terminal to the ground, then connect the output to the PV input of the inverter or the input of your controller, charge controller. Okay, so this is the cable, the DC cable. And we're just first going to measure the DC voltage. So let's see what we're getting from the panels. It's about some minutes past 5 p.m. It's already getting dark. However, the luminous intensity of the sun doesn't really affect the open circuit voltage that much. As long as the day is still bright, you're still going to get something within the range of the 5 panels times the VOC per panel. Elements of the DC voltage, open circuit voltage. So let's see what we are getting from the panels after cable losses due to the distance and all other losses. So having 224 volts. So 224 divided by 5, 44 volts per panel as VOC. So we plug it into the inverter, might be having less than that because the sun has dropped. So that's okay. So it means the panels, all the 5 panels were connected successfully. In a situation where you're having less than 200 volts, then you know that something is wrong. You have to go up there and do some corrections. So we're going to mount this stuff right here. Place it on the wall, then you mark. Much ado, we are able to successfully drill in the fissures. So let's go it inside now. Okay, For some reasons, we had to move the enclosure box from here up here. So let's just move. The same thing. The breaker is here, DC breaker, then the SPD. Now this is the connection live. First thing, connect the input from this point. We pass through this hole. Then we go to plus and minus is indicated. So here is positive, here is negative. And before we do that, it's very important for us to loop first to avoid short circuits by the time we start looping after connecting the live wires. So let's loop to the SPD first. So measure the exact length of cable that you need to loop to the SPD, then cut. So this is negative. Confirm that your connection is tight. Then just leave it there. Don't lock it yet. Then for the positive, then just fix it there. So the breaker's positive terminal. Since it's not carrying any current or voltage, I'm not going to get electrocuted, and there's no risk of short circuit. Then after this, you can lose the live wires one after the other. So start with the anyone. Let's start with the negative. So when I lose negative, open. Of course, when you touch one pole, you're not going to get electrocuted. So you just make sure you fix it in, fasten it, and screw the breaker. Then you are sure that that's done before you open the positive. So I've connected negative. Then let's connect positive. Have to be very careful. Okay, so that's done. So I've connected the breaker and I've looped it into the SPD. So what's left for me here is the output and as well as the earth terminal of the SPD. I already dug the earth pit on the ground. So all I have to do is to connect the earth wire to this terminal and connect this to the PV input of the inverter. So we're almost done. So take the same cable, measure from here to bend like this, then to come all the way down. At this point, you have the PV here. So almost the entire cable. So I'll cut here. Cut the cable, then open it. Okay. Bring it all the way down. You can lock this one since we are done passing all the cable. Okay, we're not done. I have one more cable to pass. That's it. So I have it here. Initially, it was connected to the inverter, but I'm going to remove it from the inverter now. Since we have just one earth provided, I rather connect to the source protective device first. Then I'll find ways to settle that of the inverter. So let me cut it. So this one is already connected to the ground. I've done that before. So take it. It's gonna go here. So with that, I can lock this box. I'm done with this box. So we have the DC box and we have the AC box. Well planned. And again, one thing you need to know about the source protective device. You see, when you check this top, you see we have two green stuff here. It shows green. Sometimes how the SPD works, when little surges above 500 volts and all that go into it, it's able to arrest those surges and take it to the ground. But at a certain point, if the surge voltage or the voltage spikes to a level that is too high for it to divert to the ground, it blows up completely. And then when you come, you see that this green stuff shows red. So it's good for you to always check to see at what point it's going to give you red. You just know that it has, you see the voltage higher than it's waiting and it has gone bad. You need to replace it. But the fact that it's still green doesn't mean that it's not doing its job. It's doing its job. It's helping you to arrest those small and little surges that might affect the system to the ground without you notice. So I can lock. All right. Now let's connect PV. So this is the terminal to connect PV for your inverter. You have PV plus, PV minus. Very simple. All you need to do is take this one here, locate the PV, then you put a hole on this stuff right here. Then you put the hole now. You have to be very careful. This is a hybrid inverter. Very fragile. Has fragile parts. Embedded systems. So the cable is even too long. But then no problem. I'll still manage it. Fold it inside. Let's connect negative first. This time around, I'm going to use a screwdriver. So minus has gone in. And I'll connect plus. Alright, so lock your trunking pipes and cover the inverter. Fortunately for now, we'll not be able to test to see how it's charging and to see some other details like the charging current, then also the other important parameters we need to see and examine. But let me just check if we still have some voltages going into the inverter from the PV. Regardless, the voltage even at past 6, almost to 7. So it has reduced, okay, here, has reduced to about 145 volts from the nominal 220 and 230 something, 145. So it gets to a point you get 0, maybe 20, 10 volts. So that's it. I'll just lock and that's all. Make sure you keep supporting the channel by subscribing, like the video, share the video, put in the comment section. Thank you if the video has helped you learn a thing or two. And let me know where you're watching the video from. Very important. All right, so I've powered it up. Yeah, the breaker is on now, and it's supplying inputs from the panels to the inverter. So let's check some important specifications, parameters that we need to set. So this is the time and date. We don't need that. So this AC voltage, no grid input, so it's 0 volts. Then the PV voltage is 209 within 205 to 210 volts within that range. It's about past 4 in the evening, and so this is what we are getting from the PV. So as you can see, this is the symbol that in case that the PV is charging, is entering the inverter. But right now, there's nothing going to the battery because the battery is full. To verify that, you can check the battery current. Consider the battery current is 0 amps. It means there's no current going to the battery from the solar panels. And whatever we are using right now, it's the lithium power that the panel is producing. This 357, 357 watts. So when the intensity of the sun goes up, the wattage increases and supports the battery to power the load at the moment. So the battery voltage is currently 26.8 volts. Battery amps 0 amps. There's nothing going to the battery. Then is the output 17%. So 70%, just do the math. 0.17 times 6,000 gives you the amount of load you are consuming. But you can see here in VA as 681 VA. So after power factor, you see that it is 555 watts of energy we are consuming right now. Okay, so and the panels are producing about 300 watts just now. So the panels are generating 300 watts alongside the battery to support to power the load. So the BMS is 5 amps. So 5 amps is flowing from the battery. So this is date, time, we don't need that. So I think that's all you need to know for this. And again, some important settings you need to do. We've already done the settings, but let me show you. So you just tap on this button. So you click on settings. So escape. Number one, lithium battery is a lithium battery, so we have to select lithium battery, LIB. Then the communication protocol, leave it at default. This is the bulk charging voltage, 27.8 volts. So it's the settings on the recommended voltage that was written on the battery. So we have to do it there. So if you want to modify any settings, just tap on this. Then you can modify it to 28 or whatever you want. Okay, so that's float voltage 27.5. So then this is the cutoff voltage. So at 10%, when the battery is at 10%, it's going to shut down. So to protect the BMS from shutting down. So this charging current, both from grid and solar, 70 amps. This is maximum charging current. Out of that, the grid can take maximum of 40 amps. Then the remaining 50 amps on solar panels. So this is if you want to do parallel connection. This is charging source priority, charging priority. Solar and utility. Solar and utility charges the battery together. SNU. There are other functions. You have only solar. Solar and utility charges the battery together. Okay, that's pretty much it. That's pretty it. So nothing else. We are done. Okay, we are done. So thank you very much for watching, and please, you know what to do. Subscribe to my channel. You can see there's this LI here, LI symbol, but it's not communicating because there's no communication cable. This inverter doesn't come with a port where you can connect a communication cable because if 24 volts model, the 40 volt model has communication ports alongside the battery, but this is a 24 volt battery, 24 volt inverter. You can just use a user defined, but to be able to detect that it's lithium battery, but the communication here is not going to show. So, but that's not a problem at all. So let's see one more time what panels are doing right now. This 203 volts constant 374 watts. So 374 watts, let's see what we're consuming in watts. We're consuming 553 in watts. So 374 minus 553 gives you the amount of wattage that the battery is uh, contributing to the panels to supply the load. So you can see 5 amps flowing from the battery. Okay, thank you, thank you, thank you, thank you. I'll see you in the next video. Bye for now.